Now, you can't do much about needing the screen on all the time, but you can control your application's network usage pattern. It's important to understand that in terms of power consumption, the pattern of network usage is at least as important as the total amount of data transferred. There are definite anti-patterns to network usage. It turns out that the cellular radio is designed to switch to a low-power idle mode when not in use to conserve battery life. Let's take a look at the different states the radio can be in. The cellular radio has something called the Radio Resource Controller, or RRC. It's kind of like a traffic controller for the radio. We start out in the idle state, and when we make an initial request, it takes around 100 milliseconds for us to get connected and into the active state. Once we're there, of course, we can make as many requests as we want and stay active. Once we're in the active state, though, if we don't make a request for about 1/10 of a second, we drop into a short sleep mode, which uses less power, but it'll take us up to 50 milliseconds in order to get back into active if we make a request. Then, if we don't make any requests for another 100 milliseconds, we drop into a long sleep mode. Again, we can get back to active in under 50 milliseconds. But if we don't make any requests for about 10 seconds, we drop all the way back down to idle, which will, of course, take us longer to get back into active from. The critical part about this, of course, is that each one of these states has a different power consumption profile. Idle, of course, takes the least power. Active takes the most. Short sleep and long sleep both take in between, but certainly more than idle. So it's important for us to leave the connection idle as often as possible and try not to spend too much time cycling back and forth between sleep and active.